Chapter 12, Other Eukaryotes of Microbiological Interest, Parasitic Helminths and Vectors. The learning objectives for this topic are: explain why microbiologists study large organisms such as parasitic worms, discuss the inclusion of vectors in a study of microbiology, describe the distinctive features of arachnids, list 5 diseases vectored by ticks and 2 diseases vectored by mites, describe the general physical features of insects and the features specific to various groups of insect vectors. List diseases transmitted by fleas, lice, true flies, mosquitoes, and kissing bugs. In this topic, we will cover parasitic helminths, arachnids, and insects. So the book doesn't cover the helminths very much, but one of the objectives is to learn why in the world we would cover helminths or worms in microbiology at all. Well, they have larval stages and eggs that are microscopic, and we use them to identify worm infections in humans. So there are 2 types of worms. There are the roundworms or nematodes, and this poor roundworm is being caught by a fungus and is going to get eaten. And then there are the flatworms. There's 2 different types of flatworms. We're not going to go over the terms since they're not in your textbook, but this is a tapeworm, and then there's flukes. Next up, arachnids and insects. So, once again, why are we studying these multicellular animals in microbiology? Well, because they all transmit diseases. And when you're studying the microorganism, be it virus, bacteria, or protozoa, that is being carried by these insects or arachnids, then you want to study these guys as well as a part of looking at the overall disease transmission. And arachnids or insects that carry pathogenic microbes are called vectors. Now there's 2 groups. There are the arachnids that when they're adults have 4 legs on each side for a total of 8. This one's a larval one, it only has 6. And they're more closely related to spiders. Ooh, creepy, right? Then we have the insects that have 6 legs. Now some of them have wings, some of them do not. So this one is a tick. Whenever you go camping or out into the woods, make sure you check for ticks afterwards. This is a mite. Then we have fleas. We have, this is a type of louse. This is a true fly. It's a tsetse fly. Here are mosquitoes. I'm sure you all know what they look like. And then we have the kissing bug. All of these are able to transmit disease because they all bite people. Some of them have puncturing mouth parts, others do a straightforward bite, but they're all looking to get blood from humans. So let's take a look at the diseases that they are vectors for. Here's the list of diseases that are transmitted by arachnids and the list of diseases that are transmitted by insects. Let's start out with the tick-borne diseases. I'm sure you've all heard of Lyme disease. There's also Rocky Mountain spotted fever, first characterized in the Rocky Mountains, but now it's found more in east of the Rocky Mountains. There's tularemia, relapsing fever, and tick-borne encephalitis. Now these 2 are transmitted by mites. On to the insects. Plague is transmitted by fleas. You may have remembered that from your discussions in history. Typhus is transmitted by lice. Leishmaniasis is transmitted by sandflies, which are true flies, but they're related to mosquitoes. African sleeping sickness is transmitted by a true fly, the tsetse fly. All of these are a very small selection of the diseases that are transmitted by mosquitoes. As far as I'm concerned, we should wipe out all mosquitoes, even though some of the male mosquitoes pollinate endangered plants. I can do without the endangered plants personally. And then there's Chang's disease, which is carried by the kissing bug. It's called that because it likes to bite the edge of your lip while you're sleeping. Ugh. Well, that's it for this topic. Here are the reminders of what you're supposed to get from this topic.